Assalamualaikum and hello everyone. Welcome to the video for 3.3 electrolytic cell. In this video, we will learn to state the Faraday's first law of electrolysis and apply the Faraday's first law of electrolysis in calculation. So on your notes, you'll be on page 18. Okay, here it mentioned that Faraday's first law states that the amount of substance formed during electrolysis is directly proportional to the quantity of electric charge in coulomb that flows through the electrolyte. Okay, based on the examples, later on we're going to look at a few of the examples here. Okay, the amount of substance formed is usually we're talking about the mass of metal formed during the electrolysis. Okay, is directly proportional to the quantity of electric charge. So that's why here we have M is directly proportional to Q. M ni is mass of your metal and Q is your electrical charge. Okay, so and how to calculate the Q, electrical charge, is Q is equal to IT. Okay, where the Q is electrical charge, which is the unit is in coulomb. I is the current, which is the unit is ampere, and T is time. Time must be in second. Okay, remember the unit of Q is C coulomb. Okay, and then from the Faraday's first law, here it mentioned that 1 Faraday is the amount of electric charge carried by 1 mole of electron. Okay, well, 1 Faraday is equal to 96 and 500 coulomb. So this is actually is given if the coulomb is not given in the question, we don't have to memorize it. It will be there in the list of constant. Okay, so how do we apply this one into the equation of our metal? So let's do it together. Okay, so let's look at the example here. Okay, so remember from Faraday's first law mentioned that M is directly proportional to Q. So from this equation, I want to find the Q. Actually, we can find the Q, take a Q from the equation. Okay, so this is actually a cathode where red cat or rig will gain electron. So that's why all these equation will gain the electron. Okay, so here we're talking about amount of substance formed. We're talking about our product. So 1 mole of argentum. Again, when we look here, it is equivalent to 1 mole of electron. And 1 mole of electron is actually equal to 1 Faraday. And for the 1 Faraday, we know that it is 96 and 500 coulomb. Okay, so from this equation, I want the end product to be in coulomb because remember M is directly proportional to Q and Q is actually in coulomb. So that's why I'm going to end it in coulomb. So let's look for the second example. So 1 mole aluminium, in this case 3 mole of electron or 3F. Okay, so we know that 1 mole of aluminium is equal to 3 times 96 and 500 coulomb. I want the end of it must be in coulomb itself because later the Q is equal to coulomb. So we do get 289 500 coulomb. So that is the answer for this one. Last but not least is for the zinc. So we know that from the equation, 1 mole of zinc solid is equivalent to 2 mole of electron or 2F. So I want to end it in the coulomb itself. So it's fine if you just let it like that, but I want to multiply the value straight away. So I do get 100,000 coulomb. Okay, so that is the basis of the equation. Actually, how do we apply this to find out our Faraday's law? Okay, so from here, let's look for the examples itself. So it's quite a lot of steps, but let's do it together. Okay, so for question number 1, here it mentioned an aqueous solution of copper sulfate. So for the copper sulfate here, we're just going to write down the species involved. Okay, ataupun it contains which species. So this is actually from CuSO4. Since it is an aqueous solution, so you know that we have to include H2O liquid. Okay, this is the information where this is the I 0.15 ampere and T in 5 hours. But we know that the time must be in seconds. So I'm going to change it straight away. So I do get it to be 18,000 second. The question asks for the mass of copper. So from the Faraday's first law, we know that the mass is directly proportional to Q and Q can be found out from Q equal to IT. Okay, so first step is actually I'm going to find my Q. So Q is equal to IT. So I will substitute the value. Make sure the T must be in second. Okay, so that is the Q itself. Okay, next equation, next step, remember the mass is the mass of copper itself. Okay, but then I want to know the equation for the cathode itself. I want to know how many electron. So remember, cathode is cathodic, where it gain electron. Okay, because in this case, actually at cathode we have two choices, Cu2 plus or H2O. Since here it mentioned mass of copper, so it means that copper is being selected at the cathode. So the equation is Cu2 plus equals, and then it will gain electron to form Cu solid. Okay, make sure the equation is balanced, not only the atom, but as well as the charge. So here, to balance out the charge, to get 0 on both sides, I'm going to add 2 electrons. Okay, so from here, I will write down, find the Q from the equation, the theoretical one, yang 1 mole of copper equivalent to 2 mole of electron. Okay, so from 1 mole of copper is equivalent to how many coulomb? So from here, we do get the 1 mole of coulomb is equivalent to 193,000 coulomb. Okay, so this is actually for 1 mole. Okay, but this is the theoretical one. But from the electrolysis, we only got this one, 2,700. So what should we do next is to cross multiply to know how many mole actually is involved in this electrolysis. For the 193,000 is actually theoretical. So here is the X. So we do get X is equal to 0.1399 mole. So it means that this is the number of mole of copper being electrolyzed in the reaction. The original reaction in the actual experiment, this is the mole. But then the question asks for mass. So what should we do? So we have to find the mass equal to N equal to mass divided by molar mass. Okay, so I'm just going to substitute the value. Okay, equal to mass is the question itself. Molar mass, even though it's not given in the question, but actually you can find it from the list of constant. So from your list of constant, copper here is actually 63.6 gram per mole. So here I'm just going to substitute 63.6. Then I do get my mass of copper to be 0.89 gram. So that is actually the steps for Faraday's first law. There's quite a lot of steps. But when you do the question, you can try it. You can do it. Okay, for here, the mass of copper deposited of cathode. Okay, usually in the question, it mentioned to you which is the species at cathode or at anode. So since here it give you copper, so it means that the equation at cathode must be copper, not water. Okay, for the equation for the Faraday's first law, first step you have to find the Q, and then you have to write down the equation at cathode to know the theoretical coulomb. Okay, and then you have to cross multiply to get the number of mole. The number of mole of the actual experiment, the actual value. This one is actually only theoretical. So make sure the end of the equation must be in coulomb, so that it is easier for you to do the cross multiplication. Okay, and last but not least, then you can find your mass. So it is the same step if the question asks for mass of cathode. Okay, question 2 here, since it is molten, it must be in liquid. Okay, so for the example for the next page, is the same one, the mass of cathode. So I believe you could try yourself. This is for the example number 4, the molar mass of your gold is not given in the list of constants. So please add in your notes the molar mass of gold. Okay, now let's look for question number 5. 5 and onwards is quite a different question. Okay, so here is the information given, but here it gives you the oxygen. Previously, they asked you the mass of metal, kan? But here is actually oxygen. Here it gives you the volume. Okay, how to do it? Okay, so this is all the information given, and this is the equation, where the equation of water, but make sure, is it at anode or cathode? Okay, hint for the electrolysis of water, in the middle there, it gives you the hint of your anode or cathode. Since we have oxygen, so it means that this reaction actually occur at anode. Okay, so it's fine if you do not know whether it's anode or cathode because the equation is given. Simple macam tu. Okay, but what I'm going to do now is actually I'm going to extract the information from the question. The equation dia dah bagi, tapi dia ada triknya dekat part lain lah. Okay, so here they ask you to calculate the electrical charge in coulomb. Usually to find charge in coulomb, kita guna Q equal to IT. But there is no I, there is no T given in the question. So how do we find the coulomb? So from here, actually kita akan buat macam ni. we have to do the cross multiplication. So we have to find the number of mole lah. Okay, so before we do the cross multiplication step two, first thing first, what we have to do is actually we have to compare from that equation how many coulomb, theoretical value for the coulomb. So from here, 1 mole of oxygen is equivalent to 4 mole of electron. So 4 mole of electron is the same as 4F, which is equal to 4 times 96 and 500 coulomb. Okay, so we do get the value to be 386,000 coulomb. So this is actually the theoretical for 1 mole. From this value, how many mole? So actually we do not know how to find the mole, kan? It goes back to your chapter 5, semester 1, which is PV equal to nRT. Where R is a constant. If you don't remember it, dah lama lah miss. Okay, it's actually this one. R is equal to 0.08206 L ATM per mole per Kelvin. Again, you don't have to memorize it. You can check based on the list of constants itself. So it's fine. Okay, so what should we do next? Okay, since this is actually the value, so the P must be in ATM, the volume must be in liter, temperature must be in Kelvin. So here is a millimeter mercury, you have to change it. The number of mole is the one that we're going to find out. Okay, R is given, T, it must be in Kelvin. So what I'm going to do now is actually I'm going to change the variable here to be the unit that I want. So temperature, to change it to Kelvin, we're going to add 273.15. Okay, so for the pressure itself, here is millimeter mercury. You're not familiar, it's fine. 1 atm is equal to 760. So with this value, we divide it. So we get the pressure to be 0.9934 atm. Okay, so from here, actually, we can substitute all this value into the equation of PV equal to nRT. Make sure before anything, the unit must be the same as your R, which can be cancelled out. So from here, actually, we can know the number of mole of oxygen for this reaction. So the number of mole of this reaction is actually 3.0858 exponent negative 3 mole. So from here, actually, we can do the cross multiplication to find our Q. So 1 mole is equivalent to 386 coulomb. But for this reaction, it's actually this value of mole. So we're going to find out equivalent to X coulomb. And X we will get 1191.13 coulomb. Okay, so that is for question number 5. Okay, so that's it. Okay, yang here is a bit different when we're talking about oxygen gas. Okay, the rest of the example mostly gas lah. And gas, we're talking about PV equal to nRT. Question 6 is the same. Make sure this is all the information which can be used in PV equal to nRT. So with the equation given, actually it is more simple. Let's look for question number 7. Okay, so all this information here. Okay, but the equation is not given. You have to write down yourself. But when you look at the equation itself, when you look at the species, so first thing first, check what is the species. So we have Na2SO4. So this is actually sodium sulfate. So for sodium sulfate, what should the species involve? We have Na plus equals, SO4 2 minus equals, and H2O liquid. Don't forget the liquid for equals. So this question, volume of oxygen gas produced at anode, actually it means that at anode H2O is chosen. So H2O liquid, okay, but then remember anode NOx, which is oil. Oil is losing electron. So the equation is losing electron. Okay, tapi equation of water tu apa lagi produk dia? Okay, hint is actually anode. In the middle of the lattice itself is your gas. So here is O2 gas. And then when O2 gas, the partner, it will be H plus equals. Okay, so this is the equation, but it's not balanced yet. Make sure. Chapter 3 ni pun banyak kena equation is balanced by using Archer. Check the oxygen. Oxygen is not balanced, so we're going to make it oxygen 2. And then check the hydrogen, so we're going to make the hydrogen 4. Next, calculate the charge. I want to make the charge both sides is 0, so here 4 electron. Okay, so this is actually the equation. Okay, yang lain tu, I believe you try yourself. Sama sahaja macam previous question. It's just that the equation tu, that's why you have to memorize lah actually for the water. Question 8, yang lain dia ada anode and cathode. So, make sure write down the equation first. Make sure the equation is balanced. Okay, so that's it, the end of chapter 3.